So first I want all of you should clap for yourself. I will tell you. Now I will tell you why you have clapped for yourself. Because you see what you have done from the last 5 days. So you came from different places of Odisha, different institutes of Odisha, right? First you have applied and only 40 candidates are being selected. So you are fortunate one that you have applied first, so you have got selected, right? Second thing, you have traveled to UP, right? By taking so much time, by booking train, bus, yes. Then every day you are getting up at 6:37 or 7:30, right? In the morning, right? Whether you have water heater or not, I don't know, right? You are taking the bus, then you are rushing to the class, right? By taking the ticket and you are attending the classes from 9 a.m., right? 9 to 11, okay? Then half an hour of break. 11:30 to 1:30. Then taking lunch. Then light it out. Then again literally attending the classes 3 to 5. Then again going to the hostel, right? Then you are again returning. The same thing you are doing for 5 days. So you see, you are putting a huge amount of effort. And it is easier to teach than learn. Right? So listen is different, teaching is different, learning is different. If you are learning, it is difficult than teaching. Right? So now I want these efforts what you are putting for yourself that should be fruitful. Right? So whatever effort you have put, that will be fruitful. For that you require revision. You require discussion. So now I will tell you important thing than this. Who watches cricket? All watches. So I will ask. Now can you tell me who won the 2011 World Cup final? 50 overs? No, 50 overs. India. Who got the man of the match? USA. So now in 2015 also we need a World Cup. Australia won that. Huh? Australia won that. Who won the medal? 2011 thing you have remember, 2015 you have forgotten. Now the question is why? You need to understand how our brain works. That today I am going to talk. Right? So you see, in 2011, India was in the final. So you have watched the match without skipping the advertisement. Yes, sir. Second thing, you have watched with the interest. So whatever you are watching over here, you are watching the match live. Right? Then if the same thing if you are interested over, then you have watched the same thing or you have watched with similar intensity and interest than 2015 World Cup. But you haven't done it. Why? Because you see, after India won the 2011 World Cup, after winning the match, what you have done? You have watched different news channels. And news channels में कौन क्या बोल रहा है, right? कैसे बोल रहा है? Then you are discussing with your TV watchmates, right? With whom you are watching, you are analyzing that. You are discussing with your parents, yes. And while sleeping, you are also thinking. Are you doing the same thing for what you are studying? Quickly. Next, on the next day, what you are doing, what you have done, you have gone to different newspapers. Okay. Newspapers. Then, right now also if you are getting sometime you are watching the highlights. And fortunately, unfortunately, a teacher like me comes and takes the class. He again revises. So my simple question is whether you are doing the same thing for what you are studying. So only reading and watching with interest is not enough. You need to discuss. You need to think. And you see what if you are doing that, then it will be yours. Otherwise, it will be just like 2015 World Cup. Coming Second is paying energy, then forgetting, again paying energy. So paying energy twice, forgetting. No. So you are watching interestingly. Now you have to do that extra thing. Discuss with your colleagues. Right. Teach to your colleagues, teach your friends, teach your students. Then it will be already. Okay. So today our topic is introduction to neural network and deep learning. You see, I am not introducing everything. Introduction to artificial intelligence, introduction to machine learning, introduction to neural network and deep learning. You see, base is the most important thing. If your base is strong, you can do it any time. Right? Okay, so let us see in this what I will talk. First, I will introduce what is a neural network. Right? And the most important thing every lecturer forgot, it's the mathematical model for neural network. Right? Then differentiation and its applications to neural network. I have already discussed. I will skip. I will cover it quickly. Then what is deep neural network? Then the recent advancements in deep learning, that is activation function, initialization, dropout, regularization, optimizers, stochastic gradient descent, slow accelerated gradient descent, ADA grad, ADA delta, RMS prop, atom, all of you are using. By building the deep learning. Right? Then building, how you can build and train a deep neural network using Python also, that I will tell you. Then I will tell you different hyperparameter optimization techniques. Right? If time permits, I will tell. So now let us see what is a neural network. Right? By here, don't look at that definition. Right? By hearing the term neural network, what comes into your mind? More than one neural network. Then what? By hearing the term neural, what comes into your mind? Neurology. Nervous system. Yes. Nervous system. So now you see, an artificial neural network is a mathematical model. It's a mathematical model that simulates the structure and functionality of biological nervous system. Right? It simulates. Right? It means that we will not implement it physically. We will implement it for a simulation. What it simulates? It simulates the biological nervous system. Right? Why it simulates? To make the inputs to the outputs. Right? So let us see. So before going to understand artificial intelligence, let us briefly divide biological nervous system. Right? So you see, we are also living a biological nervous system. Right? So now, can you tell me how our nervous system works? You can answer. If I will tell you if your mosquito bites you on your leg, what you will do? Go and kill that mosquito by the right hand. Yes, sir. Now you need to think step by step. Right? This is what happens. Mosquito bites to your left hand. Right? It is a receptor organ or receptive organ. Yes, sir. It gets a signal. Right? The sensor organ skin, right? It gets a signal. Then it sends the stimuli to the brain or neural. Right? Then what it does? Based on the past experience, past training, it can directly look without looking. This type of biting means it's a mosquito. Right? It will instruct what to do, what to do the action. So it will verify its agent function, yes or no. It will verify its agent function. It will map that. Shall instruct the right hand to beat the mosquito. Yes sir. Without looking its position also. Yes or no. Okay. So now you see, if you are having doubt, what is biting? I am feeling some pain. Yes or no. Then it will instruct other receptor organs like your eye. Go and see what is happening. And eye sees, it recognizes, it again sends a message that the mosquito is biting. Then again it instructs the right hand. Yes or no? So it has three things. One is receptors, which receives the stimulus. Right? Another one is neural network or brain, which makes the decision. or it is the agent function. Yes, sir. So stimulus or receptors are the sensors. These are which receive signals from the environment. Right? Next, neural network or brain makes the decision and it produces the output through the effector. That is the actuator. Yes, sir. What is it in the past? Right? So now our function is not receptors, not effectors. But how to make the decisions. Yes, sir. So we should focus on the neural network or brain. So let us get into this. So our biological nervous system or a human nervous system consists of millions of neurons with trillions of interference. Yes, sir. Million is larger or trillion is larger? Trillion is larger. So one neuron may be connected to multiple. Yes or no? Otherwise, how billions neurons will be connected by trillions of interconnections, right? Okay. So the smallest unit of processing is neuron, right? Or the neuron, right? So if I will get into a neuron, it has a dendrite, okay, which receives the input signals. Right? Then the dendrites can be of two types. One is basal dendrite and another one is apical dendrite. Basal dendrite receives the inputs from the receptive zone, whereas apical dendrite receives the output of another neuron. If you see, yes or no? As I have told you, millions of neurons with trillions of neurons. So output of a neuron may be given as input to the right. Okay. Next. So let me clear regarding dendrites is receives the input. Right? How many dendrites? So many dendrites. Yes or no? So you see at that time also you are listening to my lecture, a mosquito might be biting to you, that is also an input, right? A friend is आपको क्या कर रहे हैं वो that might be also another input, right? So many inputs are given to your brain. But now you may say that, sir, I am so much indulged in your lecture that a mosquito is biting me and I haven't recognized. Because do you know what? You are giving more weight to mind than the mosquito biting you. Yes or no? So every input is associated with that or importance, and to which input you are giving more importance, that will have a major impact on the decision. Is that clear? Okay. So now, what it does, it computes the weighted summation of all the inputs. So which input is associated with the weight? Yes, or importance level. Then it gets the weighted summation of the inputs, right? Then what it does, it produces an output response through the action. Right? Now I have told you, it gets the weighted summation of the inputs and produces an output response. Yes. So, madam, the mosquito is biting you. Are you biting the mosquito or killing the mosquito? The mosquito bite but I am providing a response. Yes, so, what input you are getting, you might not always require to produce the same thing as output. For that input, you may take an action. Yes or no? And in order to give that response based on the net input, it uses an extinction function. Right? So what input it gets net input, it passes it through an extinction function so as to provide an output response. Right? So let us see the mapping between biological neuron and the artificial neuron. So you see, dendrites are mapped to inputs, right? These weights to the dendrites are mapped to the weights to the inputs, right? Then you are having a weighted summation unit, right? But there are some neural networks which does the weighted multiplication, right? There is 5 sigma neural network, sigma by neural network, right? Instead of doing weighted summation, they are doing weighted multiplication, right? Then, after computing the net weighted summation, you are passing it through an activation function. Okay. So you will see in detail what is the activation function, what the characteristics, right? Is that clear? But I hope all of you have understood the little just like it, right? Next. So you see, given a kth neuron, so there might be many number of neurons. Yes. So I am taking a kth neuron which may have n number of inputs, right? Then each input is associated with a now there is a special input which is always one, and that is called as a paradox, right? So that is a traditional way. Now the question is why we are taking that? I will ask you because we have already studied neural network. But we want to see mathematically. So next we are computing the weighted summation of inputs. How you are computing? W1 into x1 plus W2 into x2 plus Wn into xn plus b. Yes or no? Then we are passing it through an activation function. I have written it using summation notation, right? We are passing it through an activation function so that we are getting out. So yk equal to f. Yes or no? Now can you tell me in neural network what exactly we are trying to do? ये तो आप भी पढ़ चुके हैं. Yes sir. But mathematically explain me how you are getting your x, why you are passing it to an activation function, why. So let us see. So for that, let me explain you this one with the help of a single neuron. So let us consider a single neuron with a single input, right? So single input x, okay, and weight is W, right, and a bias. So what is Vk? Vk is the net summation of the inputs is nothing but W into x plus b, right? Or Wk1 into x1 plus 3k, right? So now I am passing it through an activation function. Let us say the activation function is a linear activation function. Okay. So whatever input it takes, it produces the same thing as output. But simply for understanding what we are doing with the mathematically, right? So yk equal to same thing. What will be the f of bk? So the same thing will be produced as the yes. Can you tell me, have you seen such a equation previously? Yeah. Linearity. Yes. Yes. So now you see. So we have done this, predicting the weight based on that. Yes, collecting data, fitting a straight line. Yes or no? Fitting a straight line, then you are predicting, right? So fitting a straight line is nothing but y plus. So in numerator, then we are computing errors to adjust the slope m and intercept c. Yes or no? So square error, all these things you have gone, right? So next error calculation we are going to adjust the slope and intercept so that we will get a better fit to the line. Now why I am telling all these things again? Because this is same in neural network. So you see neural network, linear neural network, what we have done? Yk equal to W into x plus bias. This is nothing but y equal to mx. Yes or you see, you have written there is a single input. So in the one are doing W1 x1 plus bias. Yes. In straight line fitting, what you are doing? Mx plus c. Sir, suppose if there are two inputs, then multiply the equation of neural network, linear neural network, W1 x1 plus W2 x2 plus bias. The linear regression, what you have done? W1 x1 fitting है. Then yes or no? W1 x1 plus W2 x2 plus W0. Yes or no? So the same thing we are doing, right? But in linear regression we are not using activation function. Yes or no? So I have told you, while teaching you linear regression, I have told you, if the data is non-linear, should we forget linear models? No. We can use a transformation to the input, so that linear models will also behave as non-linear models. You have studied in the previous class, support vector machine, kernels, yes or no? Various kernels also you have studied. Same concept, right? So now you see, here, we will plot the error. Can you tell me, the error will be dependent on what? You see over here. So you see y equal to w into x plus bias. Yes or no? Error means y minus y hat. Yes. Y means actual output. Y hat means predicted output. How you have predicted the output? W into x plus bias. Yes or no? Weight into x plus bias. Right? So can you change x? No. Can you change y? No. But what can you change? W and b. Yes or no? In case of that M and C, right? Okay. So now you see, you can change the weight and bias so that the error will be minimized, right? So what do we do? Sir, we will start from a random point and we will do something. So I have already told you, gradient descent. Yes or no? Computing the gradient and updating the M and C, right? But here what we will update? We will update the W and B. Yes or no? Or set of W or W vector if there are multiple inputs, right? Multiple layers, so multiple number of weights, yes or no? So if there are 5 weights and 1 bias, can you tell me this error function will be a function of how many weights and biases? 5 plus 1, 5 weights, 1 bias and plus 1 error. So it is a 7-dimensional plot. Yes, and I have told you linear algebra. So what is the beauty in linear algebra? It makes you understand the concepts of lower dimension and still you can extend the same concepts to higher. Right? So now you can start from a random weight and bias, but your objective is to reach the minimum. Yes or no? So you may start from any location, but your objective is to reach the minimum. Right? How will you achieve this? So differentiation, I have already told you these things, I am skipping. Right? But the same concepts are applied over here. So I will just tell you one thing, if the derivative is 0, then what you need to do, you know that either you have reached to a minima or you have reached to a maximum. Or there is another point that is called a settle point. We will see what is that settle point, right? So now you see, if the gradient is positive, then what you are doing? You are subtracting. Yes or no? If it is negative, you are adding. Yes. So you have to add the gradient or you have to subtract the gradient to reach the minima. You have to subtract the gradient to reach the minimum. Yes or no? Right now you are at this location, right? So gradient means tan theta. Yes or no? Tan theta is negative. Nearly means you need to add so that you will reach the minimum. Yes or no? In the previous case, you see gradient is positive. Yes. So you are at this location. You need to subtract to reach the minimum. But what factor? By what factor? We will study that. Right? Is that clear? Okay. So now, if tan theta equal to 0 or if the gradient is 0, then it is either a minima or a maximum. But how will you know that whether it is minima or maxima? For that you can take a small bit or a small change in value at that location, right? So you see, let me take a function f of x equal to x square minus 3x plus 2. We know the function, right? So I will ask you, can you tell me what is the minima for the function or what is the value of x so that this function has a minimum value? That is the minimum, na? Yes or no? Yes. Can you tell me how will you get it? Compute the derivative. Equate it to 0. Yes. So compute the derivative. Okay. 2x minus 3 x equal to. Sir, both advanced. Yes. Directly he is able to answer. Right. So now my question is whether it is minima or maximum. Very good. So you can take double derivative. Right. Very good. Very good. So you see, you know everything, but you need to apply it meaningfully. Right. So you can do double derivative. But I want a similar method. Take a value near to 1.5. Let us take x equal to 1. Right? Let us take x equal to 1. Okay. So you put, if you will put x equal to 1.5, what you are getting? Minus 0.25. So if you will put x equal to 1, what you are getting? 0. Yes or no? So 0 is larger or minus 0.25 is larger? 0 is larger. So can you tell me 1.5 is a minima or maxima? Minima. Yes or no? Because near to that value 1,
x equal to 1, we are getting a larger value for the function that is 0. Yes or no? So how 1.5 can be a maximum? 1.5 is a minimum. Yes or no? This is another simple way. Yes, to check whether the solution what you have got is minimum or maximum. Yes. So now my question arises, right? So what you will do? Sir, if you know the function, compute the derivative, equate it to 0. Okay. So now, if you don't sure whether it is a minimum or maximum, compute the double derivative, equate it to 0. Right? But now my question is, in a data-driven problem, okay, in a data-driven problem, as I have told you the problems, predicting the weight, okay, or predicting the gender based on height, weight and hair length. Yes or no? How many inputs? Three inputs: height, weight and hair length. Yes or no? Okay. Now, for every height and height, weight and hair length, there is a gender. Yes. So in data-driven problem, we don't know the function that maps the input to the output. Yes or no? If we know the function, then what will we do? Forget about everything. We will compute the derivative, equate it to 0, we will get the solution. Yes or no? Or plot the graph, right? With respect to the variables. Look at the minima, right? Then select the point, means all the coefficients for the variables. Yes. It will give you the solution to the problem. Yes or no? But the problem is that for a data-driven problem, we can't plot or we don't know the equation or we don't know the function which maps the input to the output. Right? If you would have known the function, then its job is very simple. Right? Okay. So now, error functions I have already told you. Can you tell me SVM error function is what? Unimodal or multimodal? Last class पढ़े हैं. It's unimodal, right? You will always get the same solution if you will repeat it. Okay. There is a single minima. Okay. But you see, in neural network what you will have, there will be multiple minimas and multiple. Yes or no? There will be multiple minimas and multiple maximas. Now I will ask you a question. Okay. This is the error function. Yes or no? Can you tell me it is a function of what in neural network? In neural network, error function is a function of weights and biases. Or yes or no? It's a function of weights and biases because error means what? Y minus y hat whole square. You know y. What is the actual output? Y hat means what? Double transpose x plus bias or f of double transpose x plus bias. Yes or no? So can you change x? No. What can you change? You can change W, weight set and the yes or no. So error is a function of weights and biases. Yes or no. So by changing the weights and biases, you will get different errors. Yes or no. You will get different errors. Now how to get the optimal value of weights and biases so that the error will be minimum? For that, we need to use a learning algorithm or training algorithm. Is that clear? Yes or no? So, can you tell me what are the possible solutions? Sir, take different combinations of weights. Suppose there are one weight, one bias, right? Take different conditions. Sir, I will take the values 0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.1, right? Biases. Sir, I will start from -1 and go up to 1. It's up to you. Yes or no? But it will not cover the entire short space. Yes or no? So that is not an ideal way to get the value of weight and bias. So now you see in deep neural networks. Have you heard the parameters of large language models? 4 billion parameters. Are you getting? Means weights and biases. 4 billion. Are you getting? 7 billion. So if you will keep on taking different possible values, it will take 10,000 here. Yes. Are you getting? Okay. So now how to train a neural network, right? Or a deep learning model or a deep neural network. So let us start it simply. Training a single neuron model. First we will learn how to train a single neuron model, right? Then we will extend it to multi-layer neural network, right? So now you see, I have taken a single neuron with how many inputs? The number of inputs. Okay. Each input is associated with a weight. Yes or no? And a bias. Now I will ask you, why in every neuron we are taking a bias? W transpose X plus B. Yes or no? It is equivalent to what? Mx plus C. Yes. If you don't take the bias, it means what? You will only adjust the slope. You can't adjust the intercept. Yes or no? Are you getting? So in linear regression, you can get a better fit if you will adjust both slope and intercept. Yes or no? Are you getting? That's why a bias is added. Are you getting? Okay. So now, so what are the steps in training a single neuron model? Step number one, define the loss function. Right. So which loss function I have defined over here? Squared loss. Yes or no? Yi minus yi hat. There is a line. Okay, hat whole square. Right. I have told you different error functions. Yes or no? It can be absolute. It can be Cooper. Yes. So as the time proceeds, I will tell you other activations functions also, right? Or other loss functions also, right? So first step is define the loss function, right? Then step number two, define the optimization problem. Optimization means either want to maximize or you want to minimize. So loss or the error, or the name of loss is error. Okay? You want to minimize the error or you want to maximize the error? Minimize the error. So the objective function is minimization, right? Okay. Error means what? Yi minus yi hat whole square. Yes or no? Okay. So yi hat means what? F of W transpose X plus bias. Where F is the activation function, W is the weight vector, and bias is the bias, right? So you see what I have written? Yi minus F of W transpose X plus bias whole square. Yes or no? Or if I am taking for a ith input, then what I am writing? Yi minus f of W transpose xi. For xi input, what will be the right plus bias. Then you see here I have used a term regularization. Yes, sir. I have told you even regularization, right regularization, so that the weights will not become excessively large. Yes or no? So for simplicity, we will start without considering the terms, right? So what is the loss function? Yi minus yi. Step one is define the loss function. Right? Step two is yi is the rate. From the function, what you will get? No. Yi is the actual unit. Input is given height, weight, hair. Target is gender. Numerically one, numerically. So that one is the one. But through the model we compute the value. This model is y. Next step two is define the optimization problem, right? Don't write. I will send the slides. I will send the slides on daily basis. Otherwise, how will you define? मैं तो बता दिया interest and right or नहीं? Yes. So next step 3, solve the optimization problem. So how will you solve the optimization problem? First you have to randomly initialize the weight. The yellow dot, black dot, yes or no? From black dot position you need to reach the yellow dot. Dot means it's a yes or no. Vector means set of weight values and corresponding error value. Yes or no? Okay. So initially how we are generating the weights? Randomly. But don't worry, recently some strategies are there.
That we will discuss in later. Then feed forward the inputs and compute the loss function. So you see, if you will get these random weights and biases, so what you get? Sir, we get the inputs and carriers. Yes or no? So feed forward the inputs, right? Then input will be multiplied with W transpose X. Yes or no? W X plus W X two plus W X. Then we will get the bias component plus bias. Then we will pass it through an activation function F, right? It will give you the output. Then what you will do? You can compute the as y minus y or y actual output minus predicted output. Yes or no? Okay. So you see, feed forward the inputs and compute the loss function. Which loss function? That you should have defined in the step 1. Yes or no? Okay. Then update the weights. Okay. So you see what we have done? We have randomly taken the weights. That is your black dot. That we have randomly taken. What is our objective? To reach to the yellow dot. Yes or no? That is your animation. Okay. Now the question is, from black dot, how we will reach the yellow? Right? So there you need the help of gradient. Right? So you have to compute the gradient of loss with respect to the width, so that it will give you the direction in which direction you will update the width. So now can you tell me the weight updation equation is W new equal to W old plus gradient or minus gradient? Minus gradient. Why you will subtract the gradient? Because I have already explained you over here. You see, if the gradient is positive, you have to subtract. Yes or no? So that you can reach the minimum. If the gradient is negative, to reach the minimum, you have to yes or no? That's why what you will do? W new equal to W old minus meter into dou L by dou W. Yes or no? So for that, what you have to compute? You have to compute dou L by dou W. Dou L means derivative of loss with respect to yes. So now let us compute the derivative of loss with respect to it. Right. So dou L by dou W means what? It is nothing but dou L by dou F into dou F by dou W1. You see, this loss is due to what? This loss is due to what? Due to the y hat. Yes or no? How you have computed y hat? The net input you have passed through an activation function. Yes or no? So you have to compute the derivative of activation function. Then what you have done? You have multiplied it with the input. Yes? Then multiplied it with the weight, right? So you have to compute the derivative of f with respect to the weight, right? So now let us compute dou L by dou F. Dou L by dou F means what? So you see here derivative of loss with respect to activation function f. So now you see what is loss? What is loss? Y minus y hat whole square. Yes sir. Y minus y hat whole square means what? Y minus f of W transpose X plus bias whole square. Yes or no? So the activation function f is in the negative side or not? Is having a negative sign or not? Yes or no? Y minus y hat whole square. Right? Y hat means what? F of W transpose X plus bias. So the activation function has a negative sign or not? So what output you will get? You will get minus. Is that clear? Now y minus y hat whole square. So what you have done? Y minus y hat means f of W transpose X plus bias whole square. So now you see by computing the derivative of x square, what you are getting? 2x. So what you will get? 2 into y minus y. Yes sir. So what you have got? Derivative of loss with respect to activation function is minus 2 into y minus y. Right? Then dou f by dou w1. Right? Dou f by dou w1. Okay. So now you need to look into the activation function part. So f, what it is having as a parameter? F of W transpose X plus y. Yes or no? So if you want to compute dou F by dou W, then can you tell me what it will give you? or dou by dou w of wx. So wx means it should give x. So you see it will give you x, right? So dou L, derivative of loss with respect to y. Nothing but minus 2 into y minus y into if I am using a simple number. Yes or no? Is that clear? Multi-layer number. All of you are clear up to this? Yes or no? Madam. Okay. So what you have computed? You have computed the derivative. Yes or no? But what is your objective to update the weights? So how will you update the weights? W new equal to W old. W I means for the I weight. Yes sir. So W new equal to W old. You will subtract the gradient or add the gradient. So you see what I have written? Written into dou L by dou W. So what is written? There is a learning. Means by what vector of the gradient you want to update. Is that clear? So we are exactly not subtracting the gradient. We are taking a fraction of the gradient. Yes or no? What will be the value? I will tell you. No, it is only. You see the operating? Yes. No, negative also go further negative. Minimization. Negative or negative. Next, all of you are clear regarding this? Yes, sir. First one is define the loss function. Second one is define the optimization problem. Next step is solve the optimization problem. In solving the optimization problem using gradient descent, what do you have to do? Initialize the weights randomly. पहला weight होगा, that will be initialized randomly. Second step, feed forward the inputs, compute the output, compute the loss, then update the weights. Yes. So now we updated weights are updated. Then what you can do? Again feed forward the relation. Again compute the output. Again compute the loss. Again update the yes or no. So the substep 3.2 and 3.2 and 3.3 are iterative step. Yes or no? Are you getting? Okay. So now types of ANN. So I have told you single layer neural network. Yes or no? Yes, one is input layer, another one is output layer. Whereas in multi-layer, what you will have? In the input and output layer, you will have one output layer. Right? Next, why multi-layer neural networks are so important? Right? First thing is biological. Yes, sir. We are inspired from biological network. It consists of millions of neurons with trillions of. Right? That is the first motivation. Second motivation. These are universal approximators. Can approximate any nonlinear function to any desired level of equation. But what you need to do? You need to identify the right value of its parameters and hyperparameters. Hyperparameters means which is function function, right? How many number of neurons? How many number of layers? Right? Parameters means what should be the optimal value of weights, right? So if you can determine that, it can approximate any nonlinear function to any desired level of. So we will see the recent development, right? So now you see here I have plotted a graph, right? Here I have plotted a graph. It's a complicated function, right? 2 into sin x square plus s matrix of x into y, right? So you see if I will plot this, you see the complication of this graph, right? But this neural network, this multi-layer neural network can approximate that function. Right? So you see input is x and y. We can take a multiplication unit, right? So what do you have got? You can take a square unit over here. It will give you a square. You take the square root over here. You will get a square root of x. Similarly, you will get the entire function simulated through a. Right? But the problem is in data design problem you don't know that function. Yes or no? Otherwise, they design the activation functions and all the things in such a way that it should approximate the function with 100%. The problem is that we don't know that, right? And that we are actually trying to derive. Yes or no? You see, what agent does? It This is the input through sensors. Produces the output through actuators. How it makes the input through the agent. Yes, sir. Here we are using linear regression, logistic regression, support automation, random forest, right? These neural networks is agent on. Make the input to the so that your agent will become rational. Yes or no? I hope all of you are interconnecting it from the first step to the last. Right. Yes. Multi-layer neural network, right? How you are training? So sample level data is there. First you have to randomly initialize the weights. Yes. Then you have to feed forward it through the network and get the predictions. Then back to get the errors. Means compute the loss, compute the gradient of the loss. Then update the network weights. And you see these three steps are repeated until the termination criteria is yes or no. Can you tell me one termination criteria? Number of epochs is 100. One time you have updated the weights. Two times you have updated the weights for all the inputs. Epoch 2, epoch 3, 4, 5, and it is 100. Yes. Can you tell me another termination criteria when you will stop? You see, every time you are getting an error. Yes or no. If error is less than 0.1, then it is. Yes. Can you tell me another termination criteria? Rate of change of error over the iteration. Last time you could have each time you could have what is the rate of change? If the rate of change of error is below 81 threshold, yes. Similarly, based on your problem, you need to define the termination criteria. Is that clear? Are you going a little faster because of limited amount of time and you have some knowledge related to this, right? But still, I hope all of you are clear. Yes or no? But you see, this gradient descent can be of three types. One is stochastic gradient descent. One is mini-batch stochastic gradient descent. And another one is gradient descent. And these things we are listening for the past. Yes or no? So you see, stochastic gradient descent means what? So you see, in our class, there are so many faculties. So now you see, everyone has a height, weight, and area. Yes. So that is a sample, input sample. Yes or no? So that you can feed forward through the neural network, compute the output, compute the loss, right? Compute the gradient of the loss and update the weights. Yes. Then I will take second input. Feed forward the input, compute the output, compute the loss, update the weights. Then I will take third sample, right? Feed forward the output, compute the loss, compute the gradient of the loss, update the weights. This is called a stochastic gradient descent. Means what? For every input you will feed forward, compute the loss, update the weights. Are you getting? Now, what is gradient descent? Gradient descent means for first sample you will feed forward, compute the output, compute the loss. But don't update the weights. Let's take the second sample. Feed forward it, compute the output, compute the loss. So for all the samples in the class, right? Feed forward the inputs, compute the output, compute the loss. Compute the sum of loss. For all the samples. Right? Then update. Is that clear? Yes or no? And you see, iterating once through all the input is called as one epoch. Right? So now I will ask you, okay, in gradient descent, in one epoch, how many times you will update the weights? No. In that, what you told that is stochastic gradient. In gradient descent, you will update the weights once for one epoch. Yes or no? Because you see, you will compute the output for sample one, compute the loss. No. Next sample. All the samples. Compute the sum of loss. Then update the weights. Yes sir. That is in gradient descent. In stochastic gradient descent, what you will do? For the first input, or for the first sample, fill forward it, compute the output, compute the loss, update the weights. For the second sample, again. So in what one epoch means what? Traversing all the inputs. So in stochastic gradient descent, in one epoch, how many times you will update the weights? Yes, any samples are there. Yes or no? If there are n samples, you will update the weights n times. Yes or no? Yes. Now, can you guess what is minimal semester? In between of this, yes or no? So neither after one instance or neither nor after all the instances. We will take the or we will update the weights after weights of samples. Let's say weights size is A. And for first sample you have picked for a computed out to computed out. Don't know. Second, third, fourth, fifth, sixth, eighth. For all the samples you have computed out to computed loss. Then compute the sum of then update the weight once for this base. Then take another batch of inputs. Is that clear? Yes or no? So now I will ask you a question, right? If the number of samples are n, if the number of batches are b, right? Can you tell me in one epoch how many times you will update the weights? N by p upwardly. Yes or no? Is that clear? Usually the base size is set as a power of 2 for efficiency. So it can be 2, 4, 8, 16, 32, 64, 100. Now the question is, what should be the ideal base size? We will see in hyperparameter. But dynamic power. Yes, can be done. Even under surface parameter. Yes, is that clear? Yes or no? Yes. आपको तो मुंह देखते नहीं लगता है. ये समझने वाला ये से मुंडी लेने वाला है ऐसे समझने वाला है. I will test it, right? Next we will dive into medium, right? So I have told you, introduced you AI in the first lecture, right? Then in the following days you have been introduced to machine learning. Yes. Now we are going to learn deep learning within I think 45 minutes, right? We will have a glimpse of that, right? So now you see, artificial intelligence is a superset, machine learning is a subset, and deep learning is a subset of machine learning. So you see, deep learning is a type of machine learning based on artificial learning. So what I have told you in the first hour of this session, that is machine learning, right? Then what I will tell you after this, that is deep learning. It is based on artificial learning, right? In which multiple layers of processing are used to extract progressively higher level of pictures. In the first class result, I have told you in any machine learning algorithm, what is important? Pictures. Yes. Garbage in, garbage out. Better pictures, better out. Yes or no? So you see, for that pictures play a vital role. I have told you, if you will consider height to classify between males and females in an Indian scenario, it might not be a good picture, right? But you will take evidence. It will be a good picture for Indian scenario. But you go to US, it might not be. Yes or no? Their boys are also having longer hairs, right? So pictures play a vital role. So now come to the definition. Right? It is a type of machine learning based on artificial intelligence. Multiple layers of processing. If it is usually if the number of more than two, then it is usually considered as a deep learning. Right? So in every layer, what do we do? Double transposers plus bias. F of double transposers plus bias. Output of first layer will be given as input to second layer. Output of second layer will be given as input to it is in feed format mode. Output of third layer will be given as yes. So in every step what we are doing? Double transpose x plus bias. So double transpose x plus bias means what it is in the form of which equation? System of linear equations. What I have told you linear algebra, the first step. Yes or no? Getting? So w dot x plus b or ax plus b. Okay. So there what I have told you, it linearly transforms the input. Yes or no? So here also what I will do? We will transform the input. Right? Why we will transform the input? So that we can extract progressively higher level of features. Yes. So that our model should give better performance
Yes or no? And in traditional machine learning or shallow machine learning, the feature extraction, feature selection, right? Dimensionality reduction, right? Feature engineering, these all are manual process. Yes or no? You have to expect the features. You have to engineer the features. You have to select the features. What is the dimensionality of the features? By using other techniques. But in deep learning, it does it by yourself. It's right? It does it by yourself. How to do this? Right? So now I hope all of you are clear regarding the definition of deep learning. Now the question is the deep learning approach. There are two approaches, right? One is standard approach, which is usually followed by the mathematicians. Another one is engineers approach, which we also follow, right? Okay. So in the mathematicians approach, what they do? First they build theories. Then in order to prove the theories, they demonstrate experiments, right? But in the engineers approach, all of you have published some methods, yes or no? Some of you have at least published some papers or done some research. What you have done? Taken a data set, experimented, got the results, try to draw conclusions. Yes or no? So in the engineer's way, what we are doing, given a huge amount of computational power and data, people first experiment, then try to draw conclusions from the results. Yes or no? So in deep learning, most of the research is based on that. But nowadays, experimental AI has taken its line, right? People are also extensively using, trying to find the reason why the model is functioning, right? So you see, now the big question is why deep learning, right? And why now? Or why after 2012? So there are three answers, right? One is, so you see the computer vision, what that is extensively used in the vision tasks, right? That is proposed in 1998 by Leon. And the back propagation algorithm, which well understood since 1989. Time series forecasting uses long short-term memory, right? That is well understood since 1997. So, these are old concepts, right? Why it became popular in 2012 or 2015? Or again, now we are using within a span of 2 years. We are extensively using. Can you tell me why? Because of three things. One is lots of data. You see, due to the emergence of internet, a huge amount of data, okay, petabytes, exabytes of data is collected per second. Next one is hardware advancements. You see, due to the advance of CPU computing, right? You see, NVIDIA. If you purchased a stock from NVIDIA in 2010, now you should not have to worry about NVIDIA. Yes or no? Next, algorithmic advancements. Some algorithmic advancements have been made to build that internet. Right? So here I can't discuss regarding that. I can't discuss regarding advancements in hardware, but I can discuss regarding algorithmic advancements that has taken place, which made the deep learning models. Right? So the algorithmic advancements that has taken, I will discuss the algorithmic advancements in activation function, better weighted generation scheme to avoid overfitting concepts like dropout, then better optimization schemes. I have just told you the gradient distance, which you are using in gate comparison. Several advancements have already been made of that. We will see that, right? So first one is activation function. What is an activation function? Or transfer function, which transforms the inputs or weighted function of inputs to outputs. Yes or no? So why an activation function is used? To provide output response to the net input what we are receiving. Otherwise we have never take. Mosquito को bite करना. Yes or no? Mosquito को bite करना है, right? So to provide an output response to the net input what you are receiving, we are using an activation function. Another important thing is to clear only. Yes or no?
But you see, if we will not add non-linearity, it will be same as the linear relation. Yes or no? Double transpose x plus yes. Right? So to add non-linearity, activation functions are used. But you see, traditionally which activation function was extensively used? That is sigmoid activation function. Yes or no? So you have also used sigmoid activation function. Right now it is being used. It's not that it's not used. But we need to know what is the characteristics and what is the problem. Right? So first one is it is differentiable. Right? Why differentiability is required? Dou L by dou W is nothing but dou L by dou S into dou F by dou W. Yes or no? So the activation function need to be differentiable so that we can apply gradient descent on it. Yes or no? So that is a positive point, right? Next one is non-linear. It is non-linear. So it is also better, right? Two models are non-linear better. Output lies between 0 and 1. So you see the activation function. If you will put minus infinite over here, okay, then what you will get? E to the power infinite. E to the power infinite means what? Infinite. So 1 by infinite means 0. Right? Then if you will put minus infinite over here, then what you will get? If you will put infinite over here, then what you will get? E to the power minus infinite. E to the power minus infinite means 1 by e to the power infinite. 1 by e to the power infinite means 0. Yes or no? So 1 by 1 plus 0 means? Yes or no? The maximum value is 1 and minimum value is 0. Then first means what? You see the differences. F dash x equal to sigmoid of x into 1 minus sigmoid of x. Its derivative can be represented by itself. So this first. That is also required. Yes or no? Okay. But it has a problem that is called as vanishing. So you need to understand what is vanishing and why it occurs in big number. Right? So you see, you just remember that the output lies between 0 and 1. Yes or no? Can you tell me its derivative will lie between what? 0 and 1 again. Because why? You see, f of x equal to sigmoid of x. It lies between 0 and 1. 1 minus sigmoid of x. It will again lie between 0 and 1. Yes or no? So a value between 0 and 1 multiplied with a value between 0 and 1. It will be further small and between 0 and 1. Yes or no? Are you ready? So 0.5 into 0.2. What do you get? 0.1. Further small. And still in between 0 and 1. Yes or no? So now let us see what is the problem if we will only use sigmoid activation function in all the layers of deep learning. So you see in deep learning models we have 100,000 here, more than that number of layers. Yes or no? And you need to fill forward the inputs, compute the output, compute the loss, compute the gradient of the loss, update the. So how you are updating the weights? Sir, W new equal to W old minus mid time to dou L by dou W. So you need to compute dou L by dou W. Yes or no? So in a deeper neural network, how will you compute dou L by dou W? If F1 is the first layer activation function, F2 is the second layer activation function, F3 is the third layer activation function, it is nothing but dou L by dou F1, dou F1 by dou F2, dou F2 by dou F3. Yes or no? So now come to here. Here, which activation function we have used? Sigmoid. So what is the derivative? Derivative will lie within? Yes or no? Next derivative, dou F1 by dou F2 will lie within? Yes or no? So if the number of layers are large, multiplying the values between 0 to 1 will become very, very small. Yes or no? It will tend to 0. Yes. So now you see how you are updating the weights. W equal to W naught minus mid time to dou L by dou W. So dou L by dou W tends to 0. If it is a deep neural network using sigmoid activation function at all the levels, then what will happen? W naught will be same as W old. Yes or no? And how you are generating the initial weights? Randomly. So training will not. Yes or no? Are you getting a training of weights will not. Is that clear? Yes or no? Okay. So So to overcome this, the value activation function. Okay. Rectified linear unit. What is the function? F of x equal to x. If x is greater than and f of x equal to 0 and x is, so you see it is non-linear, right? And it avoids vanishing gradient. Why how vanishing gradient? You see there the derivation becomes between 0 to 1. And if you take the value of between 0 to 1, 0 to 1, 0 to 1, will tend to 0. Right? But here the derivative is f dash x equal to 1. Right? It's not between 0 to 1. Right? And it is 0 for x is less than 0. Right? Can you tell me what is the problem with this? If the input is less than 0, negative, then the derivative becomes 0. So it has a problem of dead value. So for some neurons, if the input is negative, the derivative becomes. But for which it is positive, no problem. Can you tell me a solution for this? तो 0 हो गया है, तो 0 ना करके तो उसको कर दो. Yes or no? That is called as leaky value. So you see, f of x equal to x. If x is greater than 0, but f of x equal to 0.1x. You see, I have said 0.1. It can be any value, right? 0.1, 0.2, any fraction of x, right? If x is less than 6, right? So now you see it avoids the problem of that value. Yes or no? So based on this, several activation functions, ELU, GPLU, value, SELU, SLU, so many activation functions are developed. But I hope all of you have got the concept behind it. Yes or no? Okay. Next, second algorithmic development we will go to is weight initialization. So now I have already told you error is or loss is the function of. Okay. Now I will ask you another question. How the initial weights are generated? Random. So initial weights are generated random, right? And our error function is multiple. Multiple maximas and multiple. Yes or no? So now suppose you are not fortunate, right? You have been initialized to this location, right? This point means it is a n-dimensional point. Yes or no? It represents n minus 1 weights and 1 pair. Yes or no? So you will apply gradient descent, you will update the weights based on the gradient direction. Yes or no? So what you will reach? You will reach to the corresponding minimum. And doing weight operation, right? Corresponding minimum. So this minima is a local minima or global minima? मैंने तो कुछ नहीं किया, सही प्रोग्राम को रन किया, जो साइड में किया था, उनका अच्छा रिजल्ट देना चाहिए, क्यों खराब दे रहा है? आई एम वेटिंग फॉर रिजल्ट्स आर डिफरेंट. सर मैं एक बार रन कर रहा हूँ, ये दे रहा है, दोबारा रन कर रहा हूँ, ये दे रहा है. सर ना, तो क्या करेंगे? ना तो कॉम्परेटिव मेथड है, उसका खराब रिजल्ट ले जाएंगे, तो हमारा मेथड है उसका बेस्ट रिजल्ट देगा. ये सर ना, एक्शन नॉट डू. What you have to do, you have to repeat the experiments for 10 times or 20 times. Right? Then you have to perform some statistical tests. At least you can take the average and standard deviation. Yes or no? That should be the ideal approach. If you are using a stochastic model. Right? Okay. So now you see, if you are fortunate enough, your initial weights will be generated. Yes or no? So where you will reach? You will reach the yes or no? But again, if you don't know the error function, you can't tell that what is this global minimum. Or for which value the global minimum. Right? So always whenever you are writing a paper, this method provides near optimal solutions. It can't guarantee optimal solutions. Right? So you see, if you will write optimal solutions, the reviewer will give a comment on that. You can't guarantee. You should use the term near optimal solution. Because what is the optimal solution for the data itself? We don't know.
Our objective is to minimize error. Yes or no? The error means if you are considering square error, ideal case is 0. It's saying that. So that for that data it is possible or not. So now from here what you have observed? Weight initialization plays a yes. So results of your experiment. They have experiment. So I will go through the experimentation. You can go through the basic strategies that you should follow for better weight initialization. But I will go through the strategies. So the strategies are based on training and training. So you see, I will tell you what is training and what is training by help of one example. So you see, here this is a neuron, right? How many inputs are coming to this neuron? What is the training? Its output goes to how many neurons? What is the training out? Did you understand what is training and what is training? Yes or no? So based on this, Xavier and Gloro in 2010 have developed a weight by conducting a large range of experiments. And they have found out two solutions. And it works well for which activation function? Sigmoid. What they have identified? The weights should be initialized. The weights between ith neuron of a layer to the jth neuron of next layer should be initialized from a normal distribution with mean 0 and standard deviation sigma ij. But what is sigma ij? Sigma ij is nothing but 2 by 10 plus 1. This is the first one. So if you are using TensorFlow, okay, then you can initialize the weights by using Hay uniform or Hay normal. Is that clear? Or Gloro, I think Gloro uniform or Gloro normal is there. Okay. Gloro uniform or Gloro. And it works well for signals. So similarly, in 2015, Page that's proposed an initialization. Right? And it works well for value equation. So if you are using a value equation function in your layer, then which initialization you should use? Page. Yes, sir. Whether you are for Page uniform or Hay normal. If you are using sigmoid equation function, you can use Gloro uniform or Gloro. Right? Is that clear? Next, bias variance trade-off. So you see, as the number of layers increases, then what will happen? Number of weights will also increase. Chances to overfit is also increase. Yes or no? Listen to the example here. A is learning A. Yes or no? हम बोल रहे सर ज़्यादा पढ़ाइए पूरा वक्त सब याद रखिएगा लगता जाना मैंने उसको पढ़ाया this is A, this is A, this is A, she learned it. And still I have taught her. And she learned. The angle between these two lines are 30 degrees. The angle between these two lines are 120 degrees. Next time when I am given a different shape A, she told that Papa this is not A because the angles are not 30 degrees, not 120 degrees. So it's not that, sir. Right now I am using a 20-layer deep learning model. Okay, the accuracy is, but the error is 0.5. I will use a 50-layer deep learning model. Is that clear? Okay. So it's not always. By increasing the number of layers, the accuracy will increase on test samples, right? Yes or no? Okay. So basically, time would have permitted, I will go different strategies on that. But I will give you introduction. This is an introduction. The number of layers are decreases means less number of weights chances to underfit is happens. What do you do? Sir, I have taken 40 layers. The error increases. So what I will do? I will take only 1 layer. Right? That is again a problem. Right? It will not learn properly. Right? It will have higher training layer and higher test layer. It's a no. सर बेटी को ज़्यादा पढ़ाने से वो ज़्यादा याद रखने जाए ओवरफिट हो जाता है एक बार ही पढ़ाई ठीक है. Then she will underfit. Yes or no?
So what is the ideal one? Neither underfitting nor. How to determine that? Due to variations. Yes, I will show you. If training is decreasing, training error, variation error is decreasing, then that is ideal. If training error is decreasing, but variation error is increasing, then I will show you visual, right? I will give you a website also that you can use to train your students regarding this. Okay. So you see, multi-layer neural network or the deep learning models is a higher tendency of because the number of layers are right. So you see, Jeff Hinton. I hope all of you have heard his name. Yes, sir. Jeff Hinton, Nobel Prize winner 2020. Right? He with his student, with this Srivastava, right? They have developed the concept dropout. So in dropout, what they used to do, a certain percentage of neurons are dropped out of a network. So now you see, and the dropout rate is usually between 0 to 1. Right? So now you see here in the second layer, you see how many neurons are dropped? What is the dropout rate? 0.5. So if two neurons will be dropped off, then what will happen? The corresponding weights will also be corresponding weights will also be dropped means chances to overfit will yes or no. But what you should not do? Sir, let us take drop of rate 0.9. Yes or no? Then it may underfit. So how to determine the ideal value of drop of rate? That we will see in hyper optimization with time progress. Right? Is that clear? Okay. So this I have told. Okay. Next, base normalization. Another concept. So what is normalization? Our teachers telling transforming the features to a common scale. Yes or no? Usually we are doing between 0 to 1 or minus 1 to 1. Right? Yes? So now why you do it? So that every feature has equal importance. Yes or no? Sir, I am predicting whether I am male or a person is male or female. What I am considering height in centimeter, right? Weight in kg, hair length in feet. Hair length in feet, right? So now what will happen? Sir, height in centimeter means the range is between 150 to 200. Weight in kg means usually 60 to 100. Hair length in feet means 0.01 to some value 2. Yes. So can you tell me the model we have or which feature will have higher impact on the height? Yes or no? Because it has a larger scale. What will happen? If you transfer each feature to the common scale, okay? Height will be transferred to a range between 0 to 1. It's a range divided by 1000. Weight divided by 100. Right? If all the persons will be raised between 0 to 100. Right? Then hair length maximum value is 2 feet, right? Divided by 2. Right? So all the values will come within 0 to 1. This is one way I have told, right? But there are different normalization techniques that you can do. Index normalization, Z-score normalization, vector normalization, right? So what we are doing before giving input to a model, we are scaling the data. Yes or no? Or normalizing that we are doing, sir. So why again this base normalization? So we will see, right? So you see. So in normalization you see different techniques, decimal scaling, median, index, method. Same. Next, so why we will do base normalization? Sir, the inputs we are normalizing, right? What we are doing, we are feed forwarding the inputs to the layer. Yes, sir. What we are doing, sir, f of w transpose x plus minus. Yes or no? So you see, after a few layers, the internal covariate, the internal structure of the data may shift because of this linear combination of functions, right? Or linear transformations you are doing in a layer, right? So again to take the internal covariate of the inputs in a particular data layer. We can use it. Is that clear? Yes or no? So you see what is the procedure for doing this? For a hidden layer, you can compute the mu. Mu means mean. What is the mean? It is nothing but summation of hidden layer inputs divided by number of hidden neurons, right? Then you can compute the sigma standard deviation, right? Then what you will do? You will compute the HI norm or hidden layer normalized value. How you will compute? HI minus mu divided by sigma plus epsilon. Can you tell me why epsilon is needed? The sigma will be 0. Are you getting? Then in that case it will be divided by 0. Yes or no? So that's why a small value epsilon is added in the denominator. So remember, when you are writing a long program, right, or a complicated program, and you are using division, one variable by another variable, always use a small value or add a small value to the denominator. Because if the denominator becomes 0, the program will run. Yes, sir. And you don't know in which data set. For the time it might not be coming, but in future it may come. If that is the case for your analysis, right? Next, base normalization. If you want to go through in details, you can go through the archive paper I have given. Then optimizers. Right? So I have discussed three algorithms. Yes or no? What are they? One is execution function. Second one is weight initialization scheme. Third one is drop. Next one is optimizer. Right? Optimizer means these are the algorithms which is used to tune the parameters of the model. When you write the parameters are weights and values. Yes or no? So you see, we are starting from a random weight value, right? Or you can use the event bureau or weight initializer to start from a initial, right? Then what you have to do, you need to reach the minimum by using gradient descent. We will study some advancements regarding that also, right? And you know that at minima, maxima, and saddle point. So this is a new point, saddle point. Right? I will tell you what is that. You have the gradient as yes. So now you see, I will ask you a question. Should you avoid the saddle points or should you trap in the saddle point? Saddle means what? If you see the horse के ऊपर बैठे हैं पूरी दुनिया में horse के ऊपर एक saddle है तो कैसे होता है from one side it is minimum yes जिस साइड आप पैर रखते हैं from that side it is yes neither it is a minimum nor it is a maximum but you will think that it is minimum it is also maximum is that clear so you have to avoid that. So now, stochastic gradient descent. In stochastic gradient descent, I have told you after every sample, you will compute the loss, you will compute the gradient of the loss, you will update the loss. Whereas in gradient descent, what you will do? You will feed forward the samples, compute the loss, compute the gradient of the loss, compute the loss, then compute the sum of loss for all the samples. Yes, then you will update the weights once. One equal for all the samples, right? Now I will ask you this. Okay. In which case the weight operation will be more? Number of times the weights will be operated. Gradient descent and stochastic gradient descent. So in stochastic gradient descent, the weight optimization is noisy, right? Because for after each input it will operate. Right? Whereas in gradient descent, the weight optimization is smooth. Which is less computational overhead. But to usually take a intermediate approach. That's mini-based stochastic gradient. Next, stochastic gradient descent with movement. Right? So you see in gradient descent, what do you do? W nu equal to W minus mid time to dou L by dou W. Yes or no? Whereas in stochastic gradient descent with momentum, what we do? We get a momentum term. This momentum term It is a fraction of previous iteration weight. Means for the second iteration, the momentum will be a fraction of first iteration's weight. Suppose in first iteration we will change the weightage 0.5. In second iteration what we will do? We will compute W1 equal to W minus V times rho weight by rho W. Additionally, we will add another term that is called as this momentum term, right? What is that? It's a fraction of previous iteration. Yes or no? So now, can you tell me why? Or which will be faster? Gradient descent will be faster, or stochastic gradient descent with momentum will be faster? So now I will show you one diagram. This almost quick for the yeah. So you see, here I am updating the weights. Okay. Here I am updating the weights. Right? Same thing. Right? So it is not reaching the minimum. You see, it is not reaching the minimum. Yes or no? Yes. Yes. Okay. So now here you see, here it is reaching the minimum. Okay. How it is reaching? Sir, initially it jumps quickly and gradually it slows. Yes or no? But in this case, what it does? It makes a constant change in that way. Yes or no? So it may oscillate. Yes, it may oscillate. Now what you will say? No, sir, we will gradually change the weight. So what will be the problem? It requires large number of epochs to convert. Yes or no? No, sir, we want to quickly convert. So what you will do? Sir, we will do larger weight changes. Right? Then what will happen? It may oscillate and will not reach the minimum. This side से उस side jump करेगा, उस side से इस side jump. Yes or no? So what should be the ideal one? Sir, initially दो से jump करेंगे, फिर धीरे-धीरे jump. Yes. So you see, if we would have followed that approach, then what would have happened over here? Initially it will jump from this side to this side, but gradually it will decrease. Yes or no? Are you getting? What do you see? We require also faster convergence. Yes or no? So now I will ask you a question. By using gradient descent only, right? I will get a faster convergence, or by using gradient descent with momentum, I will get a faster convergence. With momentum. Yes or no? We are additionally getting the momentum. Is that clear? Yes? Okay. Next we will go through Nesterov accelerated gradient descent. So in gradient descent with the momentum, what we have done? We get the gradient term, or subtracted the gradient term and subtracted the momentum term. But how you have subtracted? For simultaneously we have subtracted. Yes or no? X minus, X is the old weight minus momentum minus gradient. In the single line we have done. Yes or no? But in Nesterov accelerated gradient descent, what it does? It first subtracts the momentum term, right? Then computes the gradient term, then subtracts the gradient term, right? So now you will say that, sir, ये तो same चीज है, आपसे मैं 10 रुपया ले, फिर 20 रुपया ले, सिर्फ same is, I will take simultaneously 10 and 20. Yes or no? But this is not same in case of gradient. So we will see how, right? So you will see. So you see, the first example is what? Momentum based gradient descent. The second example is Nesterov accelerated gradient descent, right? So you see, in the first case, step number 1 in both the steps are same or not? Yes. Step number 2 is same. Step number 3 is same. Now come to step number 4, right? So in step number 4, here what I will add or what I will subtract? Momentum plus gradient. So it will make a larger jump. Yes or no? But here, what I will subtract? First momentum. So it will make a smaller jump or not? It has make a smaller jump. Then what I will do? I will compute the gradient. So you see, here the gradient direction is in this direction, but here the gradient direction is opposite. In this direction. Yes or no? Opposite to this one. So now you see, it will reach the minimum. Are you getting? But you see, it requires 6 steps, whereas that required 5 steps. Yes or no? Are you getting? So you see, accelerated gradient will at least give or at least perform like gradient descent with movement. And in most of the cases, it will listen. Perform better not, it will converge faster. Yes or no? It will converge. Then gradient descent with movement. Yes or no? Sir. क्या करें? But still, I am trying to create interest among you, so that you will enjoy the system. You see, finally, at the end of the day, you should enjoy it. You should feel happy. अब जो भी चीज कुछ भी बेची, इतना happy ना हो, तो you should be happy and you should be happy. That is the next. So you see, adaptive gradient, that is called as ADA gradient, right? So you see, in STD and STD plus momentum and energy, the learning rate is fixed. The learning rate is fixed means, sir, mid time. I guess how you are computing the new weights? W equal to W minus mid time to double by. Yes or no? So sir, what we are doing for all the weights, we are having a fixed learning rate. Because you see that by multiple weights, yes or no? So W I new. W new means W I new. I weights new equal to W I old minus mid time to double by old of the I. Right? But the mid time is fixed. Yes or no? In the previous optimal case. But what they have thought, the learning rate should be different for sparse features and for dense features. And for different weights, it is better to have different learning rates. Now the question is, what is a sparse feature? What is a dense feature? So you see, incrementally I am taking the concepts as the resource of select. Right? So you see, suppose I want to predict the rating of a movie. Right? So what are the features? One is movie length. Right? Second one is movie budget. Right? Third one is movie language. Right? Fourth one is Shahrukh Khan the actor. Sir, जो भी language हो, शाहरुख खान पढ़ा है तो it is a super hit movie. Yes or no? और आपका जो फेवरेट एक्टर है या एक्ट्रेस है वो है तो super hit movie. Right? So now you see, in every year, how many movies are released in Bollywood? Around 50 to 100 movies, right? But in how many movies Shahrukh Khan is the actor? One or two movies, yes or no? Because movie length is a dense feature. Every movie has a length. Movie budget is a dense feature, right? Movie language is a dense feature. In Shahrukh Khan the actor, it's fast. But which movie is acting? It is one. Of those movies he is not acting, it is. Right? So now we get neural network. Right? How many inputs it will have for this problem? 3 inputs. Yes or no? But what we are doing? W transpose x plus by s. And while updating the weights, W I new equal to W I would minus mu into dou L by dou W. We are taking the same learning rate for all weights or not? Yes or no? And dou L by dou W means what? Sir, minus 2 into y minus y8 into x. Yes or no? That is x is where? Sometimes a sparse feature, sometimes a same. Yes or no? So you see, knowingly and unknowingly we are going to do this, right? So you see, in STD what we are doing? W nu equal to W rolled minus nicta into dou L by dou W. But in Atazar what we will do? We will use nicta T. The T is the iteration counter, right? So nicta T equal to nicta. Nicta means learning rate. Initially we will take a value divided by alpha T minus 1 plus epsilon. Can you tell me why epsilon? Overcome divided by 0. Okay. What is alpha T minus 1? It is nothing but square of sum of gradients up to T minus 1 times. Is that clear? So you see, what is the denominator alpha T minus 1? It is nothing but sum of square of gradients up to T minus 1. So as the iteration will increase, the sum of the gradients will increase or not? Yes or no? So if the sum of the gradients, that is the denominator, will increase as the iteration progresses, the nitty will decrease or not? Yes or no? So initially larger value रहेगा. As the iteration progresses, the nitty will gradually increase. Yes or no? So now you see why this? Because you see, initially we want to make changes, right? So that we will have faster conversion. Right? Which always we can't keep the same learning. Otherwise, what will happen? It will do fastly. If we are having a higher learning rate, but it may overshoot, it may oscillate. I mean, yes or no? But if here also, in this case also, if you have used a learning rate in such a way that initially larger, faster convergence, then gradually it will decrease. Right? Yes or no? Are you getting? Yes. So this is called as your adaptive gradient. Okay. But can you tell me what is the problem? Time is the problem. The problem is the summation of a gradient will be too large as the iteration becomes large. Yes or no? So if the summation of a gradient will become too large, the nitty will become too small. Too small means 10 to 0. 10 to 0 means W nu equal to W minus nita into dou by dou W. If nita becomes 0, 10 to 0, nita into dou by dou W also 10 to 0. So W nu will be same as. Can you tell me a solution? You will think. You can do this. Right. Will project. So numerator or beta or project. Negative हो जाएगा. Negative में और small हो जाएगा. Close to 0. Sir, we are doing a equal weight summation. Equal weight summation means that t minus में form को exactly जितना भी weight वन t minus 2 को weight वन t minus 3 को weight वन. देखिए what we are doing? Summation of square of gradients. So हर gradient का square को हम कितना weight देते हैं? Irrespective of iteration. कुछ नहीं देते हैं, हम 1 weight देते हैं ना. What do you think? What was it, sir? We will give more weight to the descent gradient. We will gradually decrease the weight. It means what? Sir, 0.8 to t minus 1 is summation of gradient. 0.72 t minus 2 iterations gradient. 0 minus 6, 0.62, yes or no? This is called exponentially decaying weight. Are you getting? So what will happen? Like the one factor का अभी क्या हो जाए? 0.8, 0.7, yes or no? So the denominator, the sum of square of gradients, how it is increasing? That will not increase at that pace. Yes or no? Are you getting? So you see. Advantage in AutoCAD, no manual technique, but disadvantage is as the iteration increases, the learning rate will get slow, which will result in slow. Right? So, what you will do? Instead of summation of square gradients, we will use exponentially decaying summation of. Is that clear? You don't worry, I will quickly complete with you. Can you tell me what is? The same problem with other data, right? Substitute deteriorates. So what do you do? No, sir. If it is iteration counter is 1000, why are you considering from 1 to 1000? Only consider last 100 iterations, right? Forget the extreme past, right? So if you are in 1000 iteration, you will only use from 900 to 1000. Summation of square of gradients with exponential. If you are in 2000 iteration, instead of taking summation of gradients which are exponentially taken from past to 1999, it will only take exponentially taken summation of square gradients from 1900 to. Are you getting? Next one is. So I hope all of you have understood why it is so long. Just in green. Yes, you can also.
provided you have the data and you have the infrastructure, and most importantly, the interest. If interest is there, you can collect everything. Next one is atom, right? Where we will also adaptively determine the right. So now, which optimizer to use? Minimal stochastic gradient descent, small or shallow neural networks, momentum and everything can go. Then how to train a deep neural network? First one is pre-processing. You can normalize, right? In pre-processing, you use 3% rate out here, right? In pre-processing, you can do many things, right? Then weight initialization, Javier, Bloro, Sigma, K initializer for railroad. Choose the activation function. Railroad is most favorite, right? Base normalization, usually for later layers, use dropout. Choose optimizer. Favorite is adapt. Hyperparameters, active architecture, that is number of layers, number of neurons in each layer. Loss function. Yes or no? For regression problem, it is a squared loss. For classification, two class classification, it is log loss. For multi-class classification, it is multi-class loss. Right? Then the Google Colab you can use. You don't have system, you don't know how to install, don't worry. You have internet and a system, you can use. Right? Then the decision software that you can use to teach your students, right? So you see what I have told you right now, everything you can show visually. Yes. So you see, it has given some problems, right? So you see whether you want to work on a classification problem or regression problem. बोलिए किसमें काम करेंगे? Let us use a classification problem, right? So you see here is the data set. I want to separate the orange points from blue points by using a neural network, right? How many inputs? Two inputs. You can add inputs. You see x12 multiplication between x1 and x2. That is feature engineering, right? You can do x22, x2 into x2. Also x12 sine of x2. Yes or no? Now what you will do? Here you see how many neurons? Four neurons. You can add neurons. Yes or no? You can change neurons, right? Next, how many hidden layers you can add, right? Yes or no? You give it to your students, right? Let them play with it and let them try to understand the things, right? Then each layer you can change the number of neurons. Yes or no? Now you see, start training. Okay. So you see there are two lines. One is train loss, another one is test loss, right? Here you see. Okay, let me take a complicated problem, right? Let me take this one, right? I think it is harder than the previous one. Yes or no? Okay. Now let me train it, right? So you see, you can tune the learning rate. You can set the learning rate. You can set the activation function. You can set the regularization. You can set the regularization rate. Yes or no? Okay. Next, so let me train it, right? So you see, train error decreasing. Yes, yes. I want to show you this one. Yes. You see this point. Up to this is ideal training, right? But after that, what happens is training error will always reduce. Can you tell me why? It will reduce or it will at least remain same. Because based on the gradient, we are updating the weights. Yes or no? So what will happen? Gradient will always show the direction when they are trying to minimize the training error, right? But test error means what? If it is capturing noisy patterns from the data, is my doctor big, right? Say I tell right? Then it will perform poorly on the out of sample data. Yes or no? And your objective is not only to reduce the train error, but also to minimize the test. Yes or no? Okay, I hope you will first play with it so that you will learn it so that you can use it to train your other faculties and consequently. So I have given the link in the slide you can use.
Yes. Okay. Okay. So now you see the big question that I will skip. Okay. How many new inputs? How many layers? How many neurons in each layer? How many? What is the activation function? Right? What is the kernel initializer? Which optimizer? What is the learning rate? Yes. What is the base size? What is the learning rate? Right? So you see, you can use grid search, Bayesian accumulation, or store variables. Right? So you see the three possible solutions. Right? And we have proposed a solution, right, in 2024 that is published in Information Science with an impact factor of 8.1. Right? You can also go through it. Right? So encoding the deep learning model to a chromosome objective function and decoding a chromosome. Right? So due to lack of time, I am skipping it. But if you are interested, you can go through. Or you can contact me through email. Thank you very much. For the entire 5 days, what your time is fruitfully utilized. Then our time will also be fruitfully utilized.